Good afternoon to all of you. The topic is remote sensing and GIS in mapping of degraded lands. So in this, first of all, we will what do you mean by land degradations? As we know that land degradations means temporary or permanent reduction in the capacity of land, productive capacity of land. As we know, the land is comprised of soil, climate, vegetation, terrain, and other factors, water. And among these factors, soil is one of the most important factor or getting affected due to land degradation. And here, soil degradation. So we will focus mainly on the soil degradation, and we can define it. It is the process which lowers the current and the potential capability of soil to produce goods or services according to the FAO 1979. As we say, the goods means the vegetation or food grain productions which we get from the soil, and the services, the land is used for the urban, industrial and other purposes. So if soil get degraded, then we lost the production capability of the soil as well as its use for other application or other uses. So soil degradation is an important aspect of land degradations along with the degradation of vegetation or water resources. If we see the what kind of soil degradations used to take place, then it has been divided mainly in the four types of degradation. One is water erosion, that is you can define it as the loss of topsoil because that is the most productive soils which support the plant and vegetation. So water erosion, second is wind erosion which occurs in the arid and semi-arid climate, and more or less in this top layer is displaced from one place to another and get eroded. Third is chemical degradation, and in this the most important is salinization, alkalinization, means development of salt affected soils, acidification, development of acidic soils, laterization, as we see in the warm and humid climate in South India or Central India, lot of laterization is to take, that is also degraded soils, and podzolization, which is the process occurs in the humid and cool climate, generally in the Himalayan regions, where in the forest area the waste cations from the top layer of the soils move to the bottom layer of the soils. So these soils are deficient in base cations, so they lost its productivity. Fourth is physical degradation. In this, the soil there is no chemical and biological changes, but soil's density mainly affected, or we can say the bulk density of the soils is increased, porosity decreased, and the soils having less permeability and infiltration capacity. And water logging is also one of the example which comes under the physical degradation, because in this, due to water logging there is no chemical changes, but only because of water stagnation we are not able to use that land. And another degradation is there, biological degradation, although we not categorize in any class, because in this biological degradation means loss of organic matter from the soil due to mineralizations. As we know, the organic matter get decomposed and it converted into the CO2 into the atmosphere. It is not included in the classes because in arid and semi-arid area they are inherently low in organic matter, although in the humid climate organic matter is high. So that's why it is considered a biological degradation category, not as a main class. The degradation results in because of the adverse effect of which we like to know the spatial and temporal variation. Means what extent, how much area degradation is occurring, and in which time period, means in various time period the temporal variation. Both the things can be studied with the help of remote sensing and GIS. For degradation, we should know what what are the processes for degradation, because soil erosion or salt affected soils development process are different. So first we have to study the process, which how these processes are controlled by which factors or which variables, and the effects of degradation, what will be the effects on the soil. So these three important knowledge must be there to study about the land degradation. Factors which is controlling the degradations depends on the scale also, for study purpose. For example, macro scale 1 is to 1 million scales. When we take entire country as a one scale, we want to study, then there we find that the climate is the most important factor, because arid climate, desertification, salt affected and other things happen. In humid climate or sub-humid climates, you will find mainly the water erosion, and in arid climate you will find the wind erosion. Similarly, so it is macro scales we can study the climate as an important factor, but in micro scale, 50,000 scales or larger than that, we find that if you are studying a particular area, we can say the climate is fairly uniform. So climate is not a factor because climate is constant or uniform in that area. Then we find the variation is mainly because of soil properties, so that you get the soil degradation. Lithology, topography affects a lot in the degradation process. Vegetation properties, which is becomes more important because vegetation degradation is directly affecting your soil degradation. At micro scale, the short distances, spatial variability is controlled by the various processes, and we use the vegetation or soil map and terrain map to study the local variation of, or to characterize the local variation in the for soil degradation. Remote sensing can play an important role in capturing these local variations. Means remote sensing, which is very useful in studying the soil variability, studying the vegetation variability, and studying the terrain. So because of that, three factors which is largely affect the degradations can be studied with the help of remote sensing data. Remote sensing, what properties is most important for degradation point of view? If we see the remote sensing data, we are getting the synoptic coverage. Means large area we can visualize in a satellite data, so that shows that which area is degradation, where there is no degradation, means it gives us easiness to study the various kinds of degradation because of large coverage. Second is multispectral observations. Remote sensing data offering few bands, 4 spectral bands to 7 to 120 spectral bands in Hyperion satellite data. So multispectral observations are there, so we get better facility to characterize the various features in various spectral bands. Third is multi-station observation, or it is enabling us to see the stereoscopy or stereo satellite data. We can see the three-dimensional, so we can analyze the terrain features more in detail, which is one of the most important factor for the degradation. Different ground resolution and scale of imagery. Today we have the various satellite data resolution from 1 meter to 50 meters or more. So we are able to see the ground details at finer to the coarser details. Fourth is multi-date or multi-temporal observation. This is one of the important capability of the remote sensing data. We are able to get the multi-date data in a season, in a year. We can see we can find many satellite data, so that we can study the temporal growth of degradation or temporal evolution of degradation. And temporal, we can also, suppose you are seeing after 5 years intervals or 10 years interval data, you can study the growth of land degradation, or where it is, especially it is increasing the area, we can see that one. So as we know that today daily, weekly or fortnightly data are available. All these aspects, various aspects is helping us in identification of degraded lands, differentiation of those lands, and characterization. And so the synoptic view and other than characteristics, we can utilize the remote sensing data for its digital image processing through image enhancement, and you can better extract the information and classification using digital processing. Remote sensing used as a tool for mapping and modeling of land degradation. You are able to assess it, we are able to assess the spatial and temporal distribution of land degradations. And another thing that sometimes degradations we cannot see that directly. Suppose erosion, where the slight erosions we cannot see it directly on the ground. So for that one, for erosion models or other various models of degradations, we need input data which can be derived very easily with the help of remote sensing data. Here, to assess the current status of land in terms of ongoing degradation process, we need to assess natural vegetation. First, we have to assess the natural vegetation coverage, its structure means density of the vegetation. We need to study the agriculture crops, how it is performing, because growth of the agriculture crops related with your land degradation. Soil surface, because of degradation, soil surface becomes hard, crust formations used to take place, and surface sealing used to take because of that, infiltration rate is reduced. Presence of soil erosion surface features we can see, monitoring changes over time, with time what degradation has occurred, which can be assessed with the help of remote sensing data. Irrespective of degradation, any type of degradation is there, but there is need of identification of correct indicators, because degradation, how we can study it, we have to study with the help of the indicators or some diagnostic feature which is essential before any remote sensing or GIS modeling, which can be the indicators. The indicators can be detected using a variety of techniques including field observations. So we can see on the ground, that is what kind of indicators is there, and we can note down the GPS location. Then we need to collect the soil samples, because just seeing on the surface we cannot say the degradation, but if sometimes able to say the degradation, but we cannot know that is what severity of degradation is there. To analyze the severity of degradations, we go for the laboratory analysis, and then you need a remote sensing data. So combination of all three is required to study the land degradation process. Monitoring of land degradation. When we want to monitor the land degradation in 5 years intervals or 10 years intervals, what is most important? Most important part is that you have to do the radiometric calibration between image, so that digital comparison becomes easy. Otherwise, because without doing radiometric corrections, images cannot be compared. Second is temporal satellite data. You require temporal with different seasons, and time series of remote sensing data must be captured in similar period of year. For example, if I want to collected the data of June of 1995, then I need for that after 5 or 10 years interval of the same month data. If I get the same period of same big data, then it will be easy, or it will be more authentic to compare the land degradations. And third important part is the georeferencing. Georeferencing and co-registration of multi-temporal data is very much essential. Sometimes because of co-registration, we are getting the changes, but actually that is not the really change. It may be the change because of the shift of your registration or georeferencing position. So for the monitoring purpose, we have to take care of getting a proper temporal satellite data, getting radiometric calibrations, and doing the georeferencing, proper georeferencing, then only we can use for the monitoring of the land degradation. When we use the remote sensing in mapping of degraded lands, then basically in in remote sensing techniques, two techniques are there. One is the monoscopic visual interpretation of satellite data. Second is that we can do the digital image processing with digital remote sensing data. In digital image processing, we are doing the image enhancement to improve the contrast among the various features. And for improving the contrast, we are doing linear and non-linear stretching. Second image enhancement technique is the spectral indices, or you can generate various indices, band ratioing to enhance those features. And third is the spatial filtering, where we are using low pass filter or high pass filter, but for the degradation purpose, we use high pass filter. Why? Because we want to see the change in the degradation features, and degradation features means change in the boundary change can be captured with the high pass filter. So high pass filters are quite useful in the among the digital image processing. And then third is the principal component analysis. This is one of the technique used for the image enhancement. When we are having multi-temporal satellite data and we want to make a FCC, then we can compress those data in the form of using principal component analysis. Second digital image processing technique widely used is the image classification, and there are various classification methods which you have been told in earlier classes. So image classification, that is, one is the most popularly is unsupervised classification, and second is supervised classification. The details will follow. In monoscopic visual interpretation techniques, generally we do by the interpretation of false color composite. So we need a geocoded FCC at 1:50,000 scale for visual interpretation. And then questions comes when we have to collect or obtain the satellite data. So for the land degradation or wasteland mapping, we want the data when there is no vegetation cover present on the soil surface. So it means we need the data when there is no crop or crop get harvested. So after harvesting, we can take the data in month of April, May or May, June month, and in the winter season also after harvesting in the month of October, November, when there is no crop, when Kharif season crop is harvested, then we can take those data for mapping of degraded lands. Actually, degraded lands, you have to see the nature and processes how degradation occurs. According to that, we used to select the satellite data, because if salt affected soils, then we need a data of summer month, May, June month is the good one. But when we want to study the eroded lands, so sometimes we want temporal data will be helpful, because we can study we need to study the vegetation also. We need to study when there is a vegetation get dried. So in the month of April, May, or in the month of February, March is also useful in that case. What are the image characteristics? Color, tone, texture, pattern, shape, size, look, and associations enables us to identify the different kinds of degraded lands. So among the image enhancement, one is the contrast stretching or contrast adjustments. We know that a linear stretching and histogram, and you know the linear stretching means all input values of the image are converted into new values in an output map. Whereas in the histographic equalizations means it is the image is divided into number of output intervals. So here we stretch in almost in equal intervals to enhance the image quality. Principal component analysis. Although it is a data compression technique, suppose you are having Landsat TM data, which is 6-band data, and you want to make a FCC for this 6-band data. How you can make the FCC? Because in general, standard FCC is prepared with the help of 3-band data, blue, green, and you are assigning blue, green, red image display. But in a 6 band data of land spectrum, we can do the principal component analysis, and you can get the PC1 image, PC2 image, and PC3 image. And PC1 image can be displayed as red color, PC2 as a green, and PC3 as a blue. And we are able to get PCFCC. And PCFCC is a combination of all 6 bands. So we are able to see all 6 bands together. Otherwise, without principal component analysis, we cannot see all 6 bands all together. This technique is very much useful. Suppose you are having pre-monsoon data, one satellite data of pre-monsoon, one satellite data of post-monsoon, and you want to see the change in the pre-monsoon and post-monsoon if you are studying, suppose, waterlogging, or you are studying some other erosion degradation feature. Then you can make, you are having, suppose, 8 bands. If you are having IS satellites, you are having 4 bands. If you are having Landsat satellites, you may having 6 plus 6, 12 bands. And 12 bands, I want to make a principal. I want to analyze all together with the FCC. So you can make a principal component of both the satellite data, or and then you can take PC1 of both the satellite data, and you can make a FCC. So it is a data compression technique, and people have tried with the multi-temporal satellite data, the principal PCFCC. Such an image contains more information than any other combination of spectral bands. As we know, the principal component analysis, PC1 contains 88% of the variability, and in 6-band data set, and around 8% in the PC2 and 3% in PC3. So principal component analysis is one of the important tools for analyzing the degraded lines. We use the various spectral indices for analyzing the degraded lines, and among the spectral indices, you know very well the vegetation indices. For example, ratio vegetation index, normalized difference vegetation index, transformed vegetation index. These indices, vegetation indices, used to study the condition of the vegetation. And you know, if land is degraded, then the area which is degraded, the vegetation growing over that have the poor NDVI as compared to the land crop growing on the normal land. So from normal to degraded lands, we get the difference in the vegetation condition. So as we know that is the vegetation land degradation affecting directly to your vegetation. So your vegetation conditions will be affected. So it is supposed to be one of the most important parameter, remote sensing parameter, to analyze the land degradation in various forms. Besides this vegetation indices, we also use some soil spectral indices, which is known as a tasseled cap transformation. This is we can make a special spectral indices, for example, brightness index, which is also known as a soil brightness index, greenness index, wetness index. Soil brightness index, you see, you are having the 6-band is the thermal band, so that's why here it is not taken. 1, 2, 3, 4, 5, and 7. So six TM bands are taken, and the coefficients are given here. So you multiply by the coefficient into band 1, plus coefficient into band 2, plus coefficient into band 3, like that one, and you can make a brightness index image. Similarly, you can make the greenness index, which is reflecting the vegetation condition growth, and here the coefficients are in minus and some are in positive. So you can make coefficient this minus 0.28 into band 1 plus this index plus 2 into band 2 plus that, similarly that one. Wetness index, this index is used to study the waterlogged area. As its name says, it enhances the wetness feature. Your land is wet, and various wetness conditions can be enhanced with the preparing the wetness index image, which is very useful for the mapping of waterlogged area. For For IRS satellite list 1, list 2 or even list 3 satellite data, SBI and greenness index and wetness index, the coefficients are different as compared to the Landsat TM, and when we are using the IRS satellite data, then we should use these vegetation indices. Vegetation indices, soil brightness index used mainly for the studying of the salt affected soils, waterlogged area, hilly lands. Wetness index used for the qualitative delineating the moist area or waterlogged area, and various ratio of FCC, various ratio of these indices can be enhanced, increasing the contrast of the various soil features. Image classifications, you know, that is unsupervised, unsupervised classification. Unsupervised is the automatically grouping the group pixels and you are assigning the land degradation class, and supervised classifications you are giving the training set, and then you are classifying land accordingly as you are doing in case of the land use land cover. What can be the methodology? The flow diagram is shown. For the you do the visual interpretation. You need a satellite data, ancillary data, survey of topography, survey of India topography, climate data, publish other literatures, and remote sensing data. Generally, we need a two type of data: pre-monsoon and post-monsoon. Here you go for the field ground truth study. Study the soil profile or soil sample correction of the surface soil sample, sometimes soil profiles, then do the soil analysis, because we need to characterize in terms of the pH, electrical conductivity, exchangeable sodium percentage, and then you finalize the thematic maps and preparing the land degradation map. In case of the digital image processing, here digital image processing, you are taking the digital data analysis, spectral class separability analysis, you are doing the training set and spectral class separability, classification of satellite data, generating the area statistic and accuracy assessment, and preparing the mapping and monitoring of land degradation. Here you see the satellite data, you need a pre and post monsoon data, 2 season data preferably, good georeferencing is required, and then radiometric correction is required, and you can do the data enhancement, and then you assigning the training set and is defining training areas and generation of signature. So with that one you can go the digital approach. In the means, as you are using the land use land cover classification, the same method here you are using, but you are giving the training set for the degraded lands which you have identified in the field. Here I will tell, as we know that there are two types of land degradation are most important, that is your due to soil erosion process and salt affected soil. So soil erosion process is the major factors which is affecting the degradations in our land. In the country around largest area is affected by the soil erosion. Satellite remote sensing can offer the important input for the mapping of soil erosion, and you know the satellite data, they are having various resolutions of 1 meter, so we can detect the various erosion features. For example, rills. Most of the important role satellite data in erosion is mapping assessment of erosion controlling factors. So what are the factors controlling soil erosion? Soil erosion is controlled by terrain, means how the slope is there of the land, vegetation, soil type. These three factors are directly affecting the soil erosion. So terrain study and its vegetation study are very important for characterizing the erosion types. Soil erosion in the hilly landscapes could be accurately mapped using information of slope and vegetation as the various studies show. Vegetation index, we sometimes use the NDVI to study the vegetation conditions and to characterize the various vegetation, because vegetation is the one of the important factor which is governing the variability of the soil erosions. NDVI has assessing the protective vegetation cover on the erosion studies, and we need time series of NDVI. Sometimes NDVI not of one time, of 3/4 times of NDVI we study to characterize the erosion types. And erosion risk is high if low NDVI. If we are getting low NDVI value, and we are getting high rainfall intensity in that area, so we expect the soil erosion. So erosion interpretation is a tricky one because you have to see simultaneously topography and vegetation together, then you can interpret the erosion feature. Generally, with the remote sensing data which we are able to directly see is that is your gullied and ravinous land. Gullied land, which is means gully, a narrow channel forms on the surface, and that is clearly visible on the satellite data. In this we classify medium ravines and deep ravines. Medium ravines having less than 5 meter, 2.5 to 5 meter depth, but deep ravines having more than 5 meter depth, which we can see on the satellite data because of the shadow feature. Which types of erosions we are talking? That erosion we can classify into the slight, moderate, severe, very severe, and very severe. If we see the erosion types, then splash erosion is erosion 1. If you are getting only splash erosion, you can characterize slight erosion. Sheet erosion, then E2 erosion. Rill erosion, rill formations you are getting, then E3 erosion, and gully erosion E4. Network of gullies, lot of gullies you are getting, then we characterize E5 erosion. So rills and gully can be seen on the high resolution data. Suppose gully and network of gullies, we can see on the satellite data very easily on post resolution also 25 meter spatial resolution. But high resolution satellite data we are able to see the sheet erosion and rill erosions also, because the rills means less than 2 meter wide, 1 meter wide, so that can be seen only in the high resolution data. Otherwise we assume that this is the systematically, if you are getting gullies there must be rills, if you are getting rills there must be sheet. So this is means a continuous process. So these land affected area we can characterize with the help of remote sensing data. Here I am showing you a satellite data of the hilly area and the foothills. You see here that is here you are getting a very density of the gullies, or you are getting the network of gullies, lot of channels you are getting, but here the channels are less and here the channels are less than that one. And if you see the vegetation, red color is showing the vegetation permanent, here you are not vegetation, but here you see you are getting the vegetation of forest cover, and here the topography, slope is less and vegetation is there. So you can characterize it is a very severe erosion, very severe erosion, and here it is severe erosion. Because of the erosion, the topography has been changed, or you are getting the gullies in that one. And here you are getting network of gullies, and because of network of gullies, here the vegetation is removed completely, and you are getting the naked rocks and no vegetation. But here you see, here you are getting the high reflectance, and here you are getting the crops in the land. But this after E3, there should be erosion, because in the foothills, lot of soils get removed from the top layer, and because of that the soils becomes rich in sand and low in clay content, and it's giving high reflectance, and because of high reflectance you are getting light stone or white stone. But here you are getting the crop, although the farmer here also trying to take the crop, but the crop condition you see the crop is showing very light red. If you take the NDVI of this area, NDVI will be very low, but here the NDVI is good. So this is the slight erosion, and we characterize the moderate erosion. So you can say based on the topography, based on the vegetation condition, and seeing the reflectance of the surface using with the satellite data, we can interpret the different erosion features, and then we prepare the legend, that is how E2 is appearing, E3, E4 and E5, and you make a legend, then we can characterize the different types of erosion types. If you see, this is the satellite data taken of the Google Earth image showing the high resolution satellite data. You see these are the river, and this is the agricultural land having terraced agriculture. You see this is the gullies are there, but of 2.5 to 5 means medium gullies are there, And if gullies are there, then you can also assume if this is a gully, means this is a severely eroded land, then the between the land is moderately eroded, because from here the soil is also getting eroded. So if we characterize the area as the severely eroded lands, then other area will be moderately eroded, or here you can see the vegetation cover is there, but the density, here you see the density of the vegetation, and this place the density of vegetation. If both the places cannot be the same erosion, here erosion is more than this place. So we can make a legend and we can interpret the satellite data for erosion mapping. This is the IRS list 3 data, satellite data of the ravinous land along the Chambal river. You see this is the river, and along that density of ravine means gullies are there, or so close density along the river course, and this is the vegetation has been, means afforestation has been done, but in this place there is no afforestation. So you can see that is the high reflectance of this one, and ravinous lands are in general occurs along the river course, and along the river course it is because of the silty nature of the soils. Soils are in silty nature, and among the erosion we know that is the silts are highly eroded than sand and clay particles. Silts get, if the soils are silty, then there is chances of high erosion. So these are the agricultural lands, but you see the ravinous or eroded lands to be requires to be check it, otherwise this will extend to the another part. Then we come to the land degradation due to salinization and alkalinization. Means salinity and alkalinity, or in other forms you can say the salt affected soil. Salt affected soils is called due to the capillary movement. In that, what happens in arid and semi-arid climate, salts which is present within the soils or at the lower level, they come to the surface level, and they deposit on the surface and make the salt incrustation on the surface. And when salts will come to the surface, then it will give the high reflectance. So we cannot study the slight salinity, but moderate and moderate salinity or severe salinity can be delineated very moderate and strongly saline alkali soils could be delineated very easily with the help of remote sensing data. Moderately saline alkali soils, these areas are located in the fluvial plain. Although its presence we know that these lands will be found in the irrigation command area where the land is of alluvial in nature, or where although in the basaltic terrains also we get this salt affected soils in the black soils also, but these soils have pH value of 9 to 9.8 or more than 8 or 8.5, and electrical conductivity or salt concentration is ranging from 8 to 30 decisiemens per meter, and exchangeable sodium percentage is from 15 to 40. So it means these soils are high in salt content, high in sodium content, and they appear come to the surface and give the reflectance. Although the salt affected soils can be studied two ways. One is that directly when that come to the surface in the summer season and you are getting the reflectance of the surface, and you can see also with the indirectly when salt is less amount but farmers is able to grow the crop, then how we see. But certainly we know if farmers is able to grow the crop performance will be less than the crop of the normal soils. So the NDVI of this the crop affected by the salinity will be low as compared to the normal soils. So then we can study the salt affected soils with the help of indirectly with the help of the vegetation study. And you see the reflectance in the salt affected soils, that is the strongly saline soils give the high reflectance, but normal soils give the low reflectance. So we can easily, the reflectance behavior is quite significant or different, then we can map it. You see, this is the one picture of the salt affected soils of the Indo-Gangetic alluvial plains. You are getting this white signature, and this is the salt affected soils, strongly salt affected soils. And along this you are getting this bluish black color, that is the waterlogged area. This is the waterlogged area. Waterlogging and salinity in the irrigation command area supposed to be the twin problem. Both exist together. Here, based on suppose here you are getting this is this color, cyan color, and this is actually moderately salt affected soils. Why? Because here some vegetation has grown or grasses or some was grown, but they get dry in the month of April, May, but here nothing has been grown and it is still lot of salts has come to the surface, and here the vegetation grown but they get dried or they died, so this is giving the cyan color. So we can establish the lesion by studying the field, by collecting the soil samples, and then we can map the different kind of salt affected soils. And then we come to the water logging. Water logging is a temporal feature, temporal phenomena. If we see just after the rainy season, lot of area get waterlogged. All the low-lying area will get the waterlogged, and where so we can study the after the post monsoon slide data, and some waterlogging is permanent, some waterlogging is seasonal. Permanent where throughout the year you are getting the water, or in low-lying area, and you will find along the canals or river banks or coastlines. And seasonal when after monsoon, after 6 months, when it comes the summer season, or it comes October, November or December, then you are getting that water area get reduced. So you can say that is the seasonal. So to characterize where is the permanent, where is the seasonal, you need a multi-season satellite data or an year. If you take every 2 months satellite data or every month satellite, 3 months satellite data, then you are able to characterize the permanent and seasonal waterlogged area. So surface ponding or waterlogging can be easily detected, as we know that remote sensing data infrared absorb the your water bodies will absorb the infrared and giving the darker color. So generally waterlogged area we are getting the blue and cyan color. The area which remain waterlogged during both pre and monsoon season is characterized as the perennially waterlogged area. Here you see one satellite data of Indira Gandhi Canal Command area in Rajasthan. As we know, the Rajasthan is supposed to be the dry area, but after introduction of IGNP Indira Gandhi Nahar Pariyojana, this is the canal is going, and you see that along the canals you are getting the waterlogged area patches. This is the waterlogged. Where you are getting this white, these are the sand dunes. This you are getting the sand dunes. But along the water, here if you are saying this is the water permanently waterlogged, and then adjoining area where farmer is growing crop, it is not necessary, it may also be affected by waterlogging. Water table may be shallow, but there he is able to grow the crop. So waterlogging, this is the permanent, but here also waterlogging of shallow depth. That can be characterized. Here you see that because of waterlogging, it is appearing like a river, and this dark color you are seeing because of your this cloud cover. This cloud is giving shadow, so that's why it is shadow. It is not a waterlogged area. So here lot of area, because of irrigation, lot of area is getting cropped area, but here you are getting the waterlogging has been developed because of irrigation, because of irrigation canal area. Here you see the canal is going, and this is the bigger canal, and you are getting the waterlogging, and along that this white you are getting, this is the white crustacean is a salt on the surface. This is the example I am showing, that is the spectral indices. This is the where special cap transformations was developed. Here you see the satellite data, and this all whites you are seeing, this is the salt affected soils. And on the because of vegetation on the surface in month of May, the vegetation gets dried, so you are getting the sand, but here they are purely white color. So this is the salt affected soils, and you are seeing the waterlogged area also in the patches, the waterlogging, and this is the crop area. So you can, if I say the brightness index, where in brightness index I want to see that is the salt affected soils, or we can say the soil brightness index, and you say then when it was classified independently, yeah, this yellow color is showing the highly salt affected soils, and this one is a moderately salt affected soils, means you are getting the highly salt affected soils exposed in that one. But you are taking the wetness index. I told you the wetness index gives the highest information about the water logging or water bodies. So you see this all the black color. Here you will get a wetness index of the highest value, and you can classify this water log area where you are finding something difficult here to, but clearly it can be classified. So from from satellite data you can generate the wetness index image, brightness index image to study the salt affected soils and waterlogged area. Visual analysis of salt affected soils, you can do the visual analysis, that is the satellite data, and you can characterize. This is suppose all the red color is the crop, but this is the blue color is showing the waterlogged area. This is the waterlogged area, and you can characterize this is the waterlogged area. This is the supervised classifications you can do. You can map the waterlogged area. You can see the moderately salt affected, highly salt affected. So this red color is showing highly salt affected, and yellow color is showing moderately salt affected. So based on the training set, you can classify. But although there is a lot of problem in getting the supervised classification, because you will find a lot of mixing of that one training signature. That's why if you have selected some proper timing of satellite data, then mixing can be reduced or avoided. Not avoided at all, but reduced, because the difference in moderately and highly salt affected soils, although on the surface it appears same, because but in the soil, if you take the concentration of the salts, then you will find different, means a different intensity. So, but we can utilize because surface soils, it appears on the surface features, we can map that one. We need to monitor the land degradation, because how land degradation is occurring because of non-scientific use, improper management, which is increasing the land degradation process. Your salinity, water logging and soil erosion is increasing. So temporal satellite data is must for monitor the spatial growth of these land degradation types. And you see, this is the you can see this is the Indira Gandhi Canal Command area in Rajasthan in 1975. 1985, 90s and 95. You see, this is the water logging. Here you are seeing the crops are growing very well, but in 1985 this area gets the water logging, and in 90 after 5 years again water logging has increased, but in 1995 it becomes like a lake and water logging has extended like a river. So temporal satellite data are very useful in monitoring of salinity and water logging in any area, in irrigation command area. The map is shown in that is the salt affected soils has been studied in the Rohtak district of Haryana, and we have taken the satellite data of 1990 May month. Here also the same month I was talking to you that for the comparison purpose we should take the same month data so that we can better compare it. So May 1990, and here we have taken May 2000. And here we can classify, and we can see this is all the yellow color you are seeing, that is the salt affected soils. And you can see here this is in 2000 the yellowness has increased, or classification we are getting yellow color, salt or soils are shown in the yellow color. Here you are seeing a lot of area under yellow color, and in the patches also you are getting here the yellow color, so salt affected soils, but here you are not getting the salt affected soils. So in 10 years period, in 10 years the salt affected soils has increased in this patch, which is clearly visible, and here the intensity, severity of salt affected soils has increased. So very clear, and that we can do, this is done with the supervised classification of salt affected and waterlogged area. Or when satellite data was taken when there was no crop in May month period, and then we compare the both satellite data and you get the change detection map from, you can analyze in 1990 to 2000 what the change has taken place. So all the red color is shown, this is a change which was earlier not salt affected or less in interstitial soil, but now this area has increased the salt affected. So we can see the extent, which direction it has increased, how much area has increased, which is giving a very vital information for making a plan or for studying your degradation of your resources. So we can conclude that it is clear that different factors have to be considered for interpretation of remote sensing imaging. When we are going for erosion mapping, we have to take into account topography, vegetation, and image characteristics to interpret the erosion features. But before that, we should have a good knowledge of how erosion occurs, how erosion process take place. Without understanding that one, interpretation of satellite data for erosion mapping is difficult. Another is that there are various image processing methods are available, for example, supervised techniques or spectral indices, which can be utilized for mapping of the various degraded lands. Particularly in this lecture, you have seen that is how the salt soils can be mapped and how they can monitored using supervised classification and base spectral indices analysis. And for that one, temporal satellite data are quite useful in identifying and mapping of spatial growth and extent of land degradation process. I hope that you have got the idea to study the land degradation process using remote sensing data. Here I want to show this image of, this is of Rajasthan Aravalli Hills, and you see because of land degradation or erosion, you see the vegetation has been removed, there is no vegetation is existing, only land, terrain has been changed in eroded lands. You are seeing the gullies are there, and on the surface soils has been removed, and this land degradation will take ultimately to desertification. If we have not checked the land degradation, then it will lead to the desertification. And what is the difference in desertification and land degradation? The process of desertification is same. The same process which is occurring in the land degradation, when they are occurring in arid, semi-arid and dry sub-humid areas, then it is known as a desertification. Thank you.